now recording. So here we go. We're going to be deriving the equation of a circle. Of course, what is the formula for the eccentricity?
E over C over A.
Okay. So E equals C over A. And what is the eccentricity of a circle? 50-50 shot. 0. So E is 0. And 0 is C over A. That means C has to be what? Yeah, C has to be 0. That's going to help us figure out what the equation is. If we remember that a circle is just a specialized form of an ellipse, yes? Then we can start with that equation, x minus h squared plus y minus k squared equals 1, and this is over a squared and this is over b squared, one way or the other, right? Doesn't matter. If c is 0, we remember, don't we, that we have this relationship between a, b, and c, don't we? Which is what? Equals, yep, b squared plus c squared. Now if c is 0, this goes away, doesn't it? So what do we notice? Yeah, a squared is equal to b squared, which means I could take this guy right here, take it away, and make it a squared. I want you to think about what that means. Remember, the a talks about how long it is, and the b talks about how wide it is, doesn't it? So if a squared and b squared are the same, it is the same long as it is wide. And doesn't that define a circle?
Yes.
Okay, so we've got a circle. Now, if we want this in the right form, which is usually something, we don't have anything at the bottom here, do we? So how can I get rid of the a squared down there in the denominator? Yeah, so multiply everything through by a squared times a squared. That goes, and so we're left with what this becomes, which is x minus h squared plus y minus k squared equals a squared. And what does A represent? From the center to the what? To the vertex. Only for a circle, that's the radius, isn't it? So instead of writing a squared, we simply take this out and we write it as r squared. So that is where the circle comes, that's where the equation of that circle comes from. Okay, that's why we have r squared there instead of a squared. It could be a squared, it could be b squared. All right, so this is the standard form. The things that you need from this circle, or you need to graph it, are the center and the radius. So the center is, of course, at HK, and the radius is just r, which we can get from here. All right? How does everybody feel about that?
What's that R
C. Center is HK. So is everybody good with this? All right. So let's actually take and graph a circle where we have this lovely equation. Now what are we going to have to do to this equation first? Yep. Complete the square. Put it in standard form. X squared plus 6x plus y squared minus 4y equals 3, right? Move the constant over to the other end, group your x with your x squared, your y with your y squared. So now, how can I complete this?
6 2 is 3 squared.
Yep, 3 squared is what? 9? Yeah. So we have x squared plus 6x plus 9 here. And then we've got the same thing over here, y squared minus 4y plus what? Okay, why 4?
4 divided by 2 and 2.
All right. All right, plus 4. And we leave this as 3?
It's supposed to add 9 and add 4.
Yep. Add to one side, add to the other, 9 and 4, so we have 7 and 9 is 16. So this is the perfect square of what?
X plus 3.
Yep. So x plus 3, and this is what?
Y minus 2.
1 minus 2 squared. So now, the center of this circle is where?
-2.
And the radius is, yep, square root of 16, which is 4. So to graph this guy, all we really have to do, is we got to go back 3. So -3, +2 puts the center right here, and then we simply go over 4 from this guy. Oop, a little high on this one, aren't I? Did this last one. There. So we go over 3, 4, so it puts it here. Go back 4, puts it here. Go up 4, here, and go down 4 to here. And please try not to make this look like a box. I hate when people go, that is not a circle. A circle is round. Round. I'm not asking for perfection here, clearly. Mine's not perfect, but not half bad. That's the best circle I've drawn all day.
Yeah.
At least it's sort of roundish, okay? So that's really all you need is the center and the radius. Okay? So any questions on circles? Are we good? All right, so now you wanted number 3. Somebody wanted number 3 on the homework. All right. Parker, you want to bring? All right. Okay, so let's look at number 3 in the homework. Okay. Sure. All right, so number 3 on the homework had x squared plus 9y squared minus 14x plus 36y plus 49 equals 0. All right, so you've got to complete the square. So the first thing we need to do is move this guy over. It becomes minus 49 over here. Group our x's together, so we have x squared minus 14x plus 9y squared plus 36y equals that. Now, this one's easy. We can go ahead and complete the square on this, can't we? Half of -14 is 7 squared is 49, so we're going to add 49 here, and therefore we can add 49 here. This guy, however, is a problem child because there's a 9 right there, which means we have to factor out the 9. So this becomes y squared plus 4y. Half of that is 2, square it, you get 4. Only thing is you're not really adding 4. What you're really adding is 9 times 4, which is 36. That's probably where you messed up. All right, so rewriting this guy, this is the perfect square of x minus 7. This is 9 times the perfect square of y plus 2 equals 36. Now that can't be equal to 36 because it's not a circle. You know how I know it's not a circle? Because this number is not the same as that number, which means if I divide it out, I would not get the same thing underneath both of these, would I? And remember, if this is a circle, those both have to be the same. Otherwise, it's an ellipse. So this is clearly an ellipse. So we have to have a 1 here. So how do I get a 1? Yep. Divide by 36, divide by 36, divide by 36. So we have x minus 7 squared over 36 plus y plus 2 squared over 4 equals 1. So I have an ellipse. Which way is the ellipse oriented? Y horizontally?
Because the A is on the X.
Because the bigger number is with the x. So, and we know for an ellipse that's the case. So it's horizontally oriented. So let's find what we need to graph it. I won't go ahead and graph it unless you need me to, but we'll do H, K, A, and B, right? And C. Because those are what we need to graph, correct? So what is H?
7.
Yep, comes out of here, 7. What's K? Yep, comes out of here, -2. What's A?
6.
Okay, the square root of 36, which is 6. And B? Square root of 4, which is 2, and how do I find c? A squared equals, so a squared is 36 equals 4 plus c squared, so this is 32 equals c squared. C is the square root of 32, which is about 5.8, I would guess. Right? 5.7, 5.8, 5.6? Okay, so 5.6. All right. Parker, can you get it from there? So this was the part, that's the one? Okay, I suspected that was the case. That's usually where everybody messes up. If they do, you forget, you've got to add, if you're going to keep it balanced. Did everybody understand why we have to do this multiplying? Because this, if we multiply this out, you have a plus 36 here. So what you add to one side, you have to add to the other to keep it balanced. All right, so everybody's good with circles and ellipses. You feel pretty confident? Thumbs up, thumbs sideways, okay. Mostly? All right, so today what we're going to do for the rest of the day is we're going to concentrate on hyperbolas. So, here we go. Definition of a hyperbola is a hyperbola is, not if, is the locus of points. What does locus of points mean? Hello? Is there life out there? What's the locus of points?
Where they connect?
A collection of points that all have what? Something in common. They have a common characteristic. Okay? Locus of points is a set of points that have a common characteristic. They all have the same characteristic. In this case, it is such that the absolute value of the distances from the two foci are constant. All right, so what does that mean? So let's look at what an actual hyperbola looks like. If you have a hyperbola, you have these guys right here are called asymptotes. We have a vertex here and here. That's what they're describing as the shape of this curve. And then we have a foci here and a foci here. Okay? So this is a foci and this is a foci. A focus and a focus. Together they are foci. Sounds like a really bad band name, doesn't it? Yeah, there we are, foci. All right. What this means is that if we go from this point on this curve to here and to there, this is point P1, that the sum, the absolute value of the distances from the two foci is constant. So it is constant from here to here. If we took it then from some other point, let's say we did this guy right here, then that and that would be the same as those two added together. It's kind of like with an ellipse, all right? Some of those distances together, that same distance from this point to the two foci as it is from any other point to the two foci, okay? Okay, all right. Now, redraw this guy, just so you know what's going on. You didn't have to draw that. All right. So let's look at, it says the graph of a hyperbola consists of two disconnected branches that approach two asymptotes. That's why I drew the asymptotes in first. I said these two guys are asymptotes. I need those to describe from the vertex how the hyperbola goes. Remember, they don't ever go past the asymptotes. They are within the asymptotes, okay? They form these curves. Remember, it's not a parabola. This is not two mated parabolas. Okay? The graph of the hyperbola consists of two disconnected branches, branch 1 and branch 2. Okay? The curves of the branches that approach two asymptotes, asymptote 1 and asymptote 2. The midpoint of the segment with endpoints at the foci, because remember we've got a foci here and a foci here, don't we? So if we take the branch of this, in other words, if we take a segment and we connect from there through those two all the way to here, the midpoint turns out where those two asymptotes cross. And what would we call that point?
The center point.
The center point. This is the center. Something are at the intersections of this segment and each branch of the curve. In other words, what is this point and what is this point called? Yes. Vertices. Vertex 1 and vertex 2. Here and here. Okay. Going through this guy right here, we have a line. All right? It's all symmetric, isn't it? Would you agree? Okay, so through this guy. Oh, I don't want that color. I want some other color. So the foci, the vertices, the center all lie along this line. And it's symmetrical to either side of it, correct? All right, this is called the transverse axis. And this transverse axis, which really is from here to here, it has a length of 2a, which means from here to here it is 2a. If it is 2a, then how far is it from the center to one of the vertices? A. That is good. So, let's keep that in mind. So from here to here is distance A. Now, there is another axis that's perpendicular to the transverse and passes through the center. So now we have this other guy that passes through this one. Yep. It is perpendicular to this one, goes here. It is called the conjugate axis. Conjugate axis. It is perpendicular transverse, passes through the center, and has a length of 2b. All right. Now, we need to talk about something here, and I'm going to use a different color to show you. If you go through the vertices over to the asymptotes on both sides, this way and this way, and you go down, look what you get. You get a rectangular box whose length is 2a and whose width is 2b. So this distance from here to here, this distance from here to here is b. Okay? And distance is b. It's hard to tell, so I'm going to put it in black here again. That distance is b. Now, we have one more distance we need, which is from the center to the foci. Guess what that distance is going to be? You think? So that distance is going to be, indeed, is going to be c. So from here to the foci is c. However, here's the cool thing. I want you to look at something. A and B are perpendicular to each other, aren't they? So guess what? This length from here and this makes a right triangle, doesn't it? Don't we have a right triangle where we have A here, we have B here, at a right angle, so this distance from here to here would be, do you think it's the same one as this? Let's look. That distance there?
So we're going to have this fake one and the real one on the test?
Yes. This distance from here to here is exactly the same as the distance from the center to the foci. So that distance from the center to the foci C is also the same as from the corner of this box. It's across the diagonal corner of this box. It's kind of cool if you think about it. It just works out nicely that way. All right. So, We've got the vertical hyperbola drawn, so I'm not going to erase it. We're just going to fill all this in. So our vertical hyperbola looks like this over here. So let's fill this stuff in. The equation for a vertical hyperbola is y minus k squared minus x minus h squared equals 1. This one is over a squared and this one is over b squared. The only difference between this equation and the equation of an ellipse is what?
It's a minus.
A minus sign, and that makes a big difference. You get a difference between something that opens in like this, doesn't it? Versus something that now opens out that way, doesn't it? Can you kind of see where it's coming from? You can see that ellipse, and if you split the ellipse at the center and you kind of flipped it out and kept it going, it would kind of look that way. It's not exactly the same, but you get the general idea. That minus sign makes all the difference in the world. All right? So now, we need to fill in the center, the foci, the transverse axis, the conjugate, the asymptotes, and the vertices. Forgot to put those on for some reason. So, let's talk about the fact that if this is vertical, let me point something out to you. Vertical, and what came first? Very funny. Notice the y came first, didn't it? This is not like the ellipse in that you look for which one has the bigger number under it. It's whichever one comes first. I want you to think about, with an ellipse, it was plus, so you could have put them in any order you wanted, couldn't you? Which means we had to look for which one had the bigger number underneath it as the denominator to see which way it was oriented. Here, with subtraction, you can't flip the order, or you flip the problem. So whichever one comes first in there, before the subtraction sign, is the dominant axis, okay? And a squared is always underneath the first one. These don't swap around. So it's always a squared b squared here. All right. So now, let's talk about the center. The center is going to be at, guess what? Take a stab in the dark. Somebody said it. Yeah, HK. That doesn't change. So now, let's look at the vertices next. From the center to the vertex is what distance here? It's A, isn't it? So which one's going to change if this thing is oriented vertically? Is the X, in other words, is the H going to change or is the K going to change? Why the K? Because we're going up or, and that would affect the Y, which is K. So the H is going to stay the same, and the K is going to change up or down by how much? Yeah, A. Now, the foci. Would you agree that the foci are in that same order, weren't they? So which one's going to change, the H to the K? And the K. Only this time, how much is it going to change by?
C.
Yes, because from here to here is C. Or there. All right? Talking about the transverse axis. The transverse axis, of course, is oriented the same way the hyperbola is, which in this case is vertical. It passes through the center. So a vertical line that passes through the center, its equation is going to be what? What?
X equals H.
Yes. X equals H. Therefore, the conjugate axis is a horizontal line that passes through the center. So what is its equation going to be?
Y equals K.
Y equals K. Now, the asymptotes. There is an equation for the asymptotes. It's very easy. It comes from the point-slope form of a line. In other words, do you remember this formula from Algebra 1? Y minus y1 equals m times x minus x sub 1. That, you've got a point and a slope. That's the point-slope form of a line. Do we have a point that both of these pass through?
HK.
Yeah. So this becomes K. This becomes H. Now, we've got one that goes this way and one that goes that way, so this makes it plus or minus. And now we just need to know what the slope is. But guess what? This lovely little box here tells us what the slope is. Slope is defined as rise over run. How much is the rise? And how much is the run? Yeah. A over B. Simple enough, isn't it? So what do you think? We've got the formulas down, we've worked through it. So now we're going to take this and we're going to look at one for horizontal. Horizontal, all it's going to change is, instead of being y minus k here, what's it going to be? X minus h, it's still going to be over a squared and b squared. Instead of this being x equals h and y equals k, we're going to, instead of this being h and k plus a, it's going to be plus or minus and k, and this is going to be h plus or minus and k, right? And this guy is going to change, this will stay the same, but this guy is going to change because my rise over run now is going to be, the a is going to be this way, isn't it? And the b is going to be, so this is going to also flip over, okay? So let's very quickly draw this out and fill those in. You can go ahead and start filling them in because you know now what they're going to be, and then we'll jump right into, let's do some examples. So for a horizontal hyperbola, remember we've got this guy, we've got asymptote 1, asymptote 2. This time it's going this way, and this way. Vertex 1, this is the center, this is vertex 2, this is foci 2, this is foci 1. We have the transverse axis going this way now. And we have the conjugate axis going that way, right through the center. If we go up from the vertex here and down to this line, up and down again, we have this same what? We have the same box, don't we? It's a terrible box, but you get the idea. And we know the distance from here to here is what? Yep. The distance from here to here? Mm-hmm. And the distance from, I wish I had more colors. Nope, I've used that one, used that one, used that one. Doggone it, I've used all of them. Yellow, pop. And from here to here is what?
C.
That is C. Okay. So let's fill this in. Looking at all these pieces. The equation this time, since it is horizontal, we said x minus h squared over a squared minus y minus k squared over b squared equals 1. The center is still at what? HK. Going to add the vertices down here again. The vertices are going to be, which one's going to change this time, the H or the K? Yep, the H is going to change, so these are going to be H plus or minus what? What's the relationship here, from here to here? Yeah, plus or minus A. And this is K. Now the foci are going to still be H plus or minus, but what are we going to be plus or minus this time? Yep, C. H plus or minus CK. This time the transverse axis is a horizontal line, so it's what? Yep. So conjugate's going to be And we said the asymptotes would still be y minus k equals plus or minus this time instead of b over, or what was it last time? Well, it doesn't even matter. Rise over run. Rise is, run is. So this time it's b over a and x minus h. Okay? What, is your mind blown about something?
No.
He did it in the wrong one.
Oops. Yeah, that's right. Okay. Rather than doing that, why don't you just scratch out horizontal and vertical?
Because I already wrote all the stuff.
Okay. All right. So let's talk about how we graph. Two graphs. If you look at the instructions there, what the instructions say is they say basically you need the same things to graph these that you need to graph an ellipse because it's the same letters coming out of the formulas, isn't it? X, you've got have your H, your K, your A, your B, and then we'll eventually from A and B have to find C, won't we? All right. So let's look at this. Now here's the thing though. When we graph, let me give you an order here. When we graph, the first thing we put on the graph is we put on the center. Then I always put on the vertices. Whichever way they're going, I put the vertices on because I figure out which way it's oriented. Okay? After I put the vertices on, I'm going to put my asymptotes in next. Because you cannot draw your curve without the asymptotes, can you? So once the asymptotes are in, we can draw our curves in, and then we can put our foci in. Okay? That's typically a good order. Center, vertices, asymptotes, draw your curves, put your foci in. All right? Is everybody good with that? That's our general plan. So let's actually graph some. So let's pick one. Where are my notes? So y'all look at your examples and tell me you want to do example 1 or example 2. We'll do example 3.
Huh?
You want to do example 1 or example 2?
We're doing figure
Okay.
Let's do example 1 because everybody always gets thrown off by examples like this one. I don't even know why. Y squared over 9 minus x squared over 25 equals 1. So first things first, let's figure out which way it's oriented.
This one's minus, this one's
Okay, why is it vertical?
No,
That comes first, right? Okay, so it is vertically. Now we need an H, we need a K, we need an A, we need a B, and then eventually we'll find a C, won't we? So what is H?
0.
Yeah, you'd be surprised how many people look at this and the first thing they think is 1. I don't know why. You only know